zeroth law of thermodynamics that give you the concept of temperature. Temperature of the body or temperature of the system that represent the intensity of hotness or coldness of the body, and it determine the direction of a flow of heat when two bodies are in contact. So experimentally we can observe this thing, the direction of flow of heat that will be from high temperature to low temperature. Clear? And when there is no exchange of heat, we can say the bodies or systems are in thermal equilibrium. So at that time, the temperature of both the system, that is same one, or in other words, we can say the intensity of hotness for both the systems, that is same one. Now we have to think about the heat, internal energy and work done. Okay. Now, first of all, heat that is nothing but a form of energy. Okay. Now, internal energy means what? So, internal energy, that is nothing but the summation of kinetic energy and potential energy of the molecules of system. So, if you take the summation of kinetic energy and potential energy of the molecules of the system, then it will give you total internal energy of the system. Clear first of all this thing? The internal energy of the system that depends on the state of the system, and state of the system that will be decided by the physical quantities like the pressure of the system, volume of the system, temperature of the system, like that. Okay. Now see, suppose we have a piston cylinder like system. We have a piston cylinder like system, and now in this piston cylinder like system, suppose the gas is filled. First think like that, here this inlet and outlet valves which are represented here in the figure are not there. Are not there. Okay. Now suppose the heat is supplied to the gas. Then expansion of gas will take place. So here on the piston, some force will exert in upward direction. Suppose area of the piston, that is A, and the pressure X on it, that is P, then we can say the force act on the piston, that is pressure into area. Now suppose under the effect of this force, your piston is displaced by some amount delta X. Then we can say here the mechanical work is done, that is F into delta X. So heat is given to the gas, which is called working substance. It absorbs some heat, and as a result of it, we get some mechanical work. It implies that scientists came to know about this thing. Yes, heat can be converted into mechanical work. Heat can be converted into mechanical work. Clear to all of you this concept? For very small displacement of the piston, that is not the useful or fruitful mechanical work. Suppose the piston is connected to a wheel with shaft, and here we make an arrangement of inlet and outlet valve. Now, when the heat is absorbed by this gas and the maximum expansion of the gas takes place, under the effect of which the maximum displacement of the piston takes place. So shaft will move up and now wheel will be rotated. Okay. Now that particular heated gas is suppose taken out and passed through the cold reservoir where it releases some heat, and now that cooled one is entered again to the cylinder through inlet valve, and now again when temperature is less here, this piston automatically move in downward direction, and again when it absorb the heat it move up. So the motion of the piston up down up down up down up down, that will continue, and due to that this wheel will be rotated continuously. Suppose you connect this rotating wheel with the pump, then you can lift the water from underground tank to overhead tank. That is the fruitful mechanical work. Clear to all of you? Now suppose we prepare the PV diagram for the working of the system. Okay. In that, suppose the initial thermodynamic state here on the PV diagram, that is represented by I, and final thermodynamic state is represented by F. Now here suppose first keeping pressure constant, the volume of the system is made from Vi to Vf, and then after by keeping volume constant, pressure is decreased and it is made Pi to Pf, and system is moved from initial to final thermodynamic state. Another path, that is this B path. Then third path means first the pressure is decreased from Pi to Pf by keeping the volume constant, and then after by keeping pressure constant the volume is increased up to Vf, and the system is moved from initial to final thermodynamic state. So you can choose different paths to move the system from initial to final thermodynamic states. Clear? So here experimentally we can observe this thing. If the system is moved from initial to final thermodynamic system through different paths, then heat absorbed by the system and the work done by the system are different one. Now suppose, as per example, first we consider the path IAF, and when the system is moved from initial to final on the path IAF, the heat absorbed by the system is QA, and suppose work done is WA. Then if you choose the path IBF, then the heat absorbed, that will be QB, and work done WB, means different than initial one. Then third path ICF, then again the heat absorbed, that will be different one. So say it is QC, and work done, that is WC. Clear to all of you? Now here we can observe one interesting thing. That is this one. If the system is moved from initial to final thermodynamic state through any path, then no doubt the heat absorbed by the system and the work done, that will be different for different paths. But the difference of heat absorbed and work done, that is same one for any path. It implies that the difference of heat absorbed and work done, that does not depends on the path chosen to move the system from initial to final. It depends only on the initial and final state. It does not depends on the path. Clear?